going to have is a panel discussion to talk about design and production that drive IoT manufacturing. So this is going to be moderated by Ed Hightower, who is the chair of the IoT Forum for North Texas at Tech Titans. Also a member of Tech Titans. All the people you see up here are Tech Titans members. We have Mike Wilkinson, who is the president of Paragon Innovation. I know it says Tech Titans here, I know better. Okay. We have Jim Kokel, who is the president and CEO of Wavetrix. We have, which is not on my sheet, we have Mobeen Khan, who is vice president IoT at AT&T. So AT&T, I'm sure, has a point of view on IoT, especially in the manufacturing space. So without further ado, Ed?
I appreciate it. Yeah. Thank you, Pete. Appreciate it. Pete was the former chairman of the IoT Forum there at Tech Titans, so we're glad to have him in our marketplace. So today's session is brought to us by Tech Titans, and it's a technology association here in North Dallas, in North Texas, and it has over 375 corporate members and individual members as well. And they get involved in 5 major initiatives, and one is STEM education, then innovation, both with startup companies, entrepreneurs, and they work with universities to help the entrepreneurial endeavors that are in the area. They do legislative advocacy at the state of Texas, and they help with branding and marketing for entrepreneurs and the companies, the tech companies here in the North Texas area. And the last is the programs and forums that they put on, and we're part of that. We're the IoT Forum, as well as the Design and Manufacturing Forum, which Gary Tell is the chairman of it. He's in the back of the room and will be helping today with questions and moving the mic around. And we have actually 8 different programs, 8 different forums that we put on, artificial intelligence, data analytics, blockchain, and several other ones as well. So if you have an interest, go to techtitans.com or do a Google search for Tech Titans, and you'll get more information about those. Let me go into a little bit more on each of our panelists here. Mike Wilkinson is the CEO and founder of Paragon Innovations. Mike leads the business strategy and the vision and product design and development and customer relations for them. His company's been around since 1990, so he's been successful over all these years and has grown.
I wouldn't say that.
Okay. He's still in business, so to say. So he's doing very well. He has customers like 3M and B, Braun Medical, Hitachi, Medtronics, Motorola, Siemens, and Mitsubishi. So he's a very accomplished man. He graduated from Texas A&M in 1986. Woo! There you go. And he helps with the Advisory Council for Texas A&M's McFerrin Center for Entrepreneurship, and he serves on the Industrial Advisory Board for Texas A&M's Engineering Department. So he's a very not only hard-working guy, but he gives back to the community. We're really glad to have him up here today. Now, Jim Kokel is the CEO and founder of Wavetrix. And Jim has many years of experience developing and marketing and selling communication systems. And prior to founding Wavetrix, he was the director of marketing for Broadband Gateways, where he focused on positioning the company's products and developing strategic partnerships. Previously, he created softband software radio product line for Blue Wave System, which was acquired by Motorola Google at some point. His experience extends across a broad range of communication systems, from cellular networks to free space optical systems. He made a presentation last month, and at his facility there in Richardson. It was quite fascinating how he combines technologies to create IoT solutions for the supply chain. So we'll get into a bit more of that in a little while. And our third panelist here is Mobeen Khan, and as Pete said, he is an AVP at AT&T. He's responsible for the Internet of Things strategy and product management for AT&T. We're glad to have him on our panel. He is a mobility and software technology executive. He's an entrepreneur and an investor. As the AT&T strategy and products management executive at AT&T, he's responsible for products and P&L for the end-to-end IoT solutions servicing large, mid-market, and government customers. Offers extend globally. from devices and platforms and vertical solutions and professional services. So he covers the gamut. We're very glad to have him on the panel here to give us a background on all the things that he and AT&T are seeing going on in the marketplace. Now, I'm Ed Hightower. I'll be the moderator for the session. As Pete said, I'm now the lead tri-chair for the TechTitans IoT Forum. I've been on several different committees. In fact, I've been in this market in the Dallas area for 30 years. I've been part of TechTitans for the last 20 years and been in, ran several different groups for them as well. So it's an awesome organization. Come join us if you'd like to be a part of this and help us to make the United States, the nation, and the world know about our technological capabilities here in the Dallas area. We have a tremendous tech community in this North Texas area. I'm presently working, have a consulting company called IIoT and Beyond. I'm working with a startup company called EdgeTenso. They produce an artificial intelligence that resides at the edge. It works on low-cost hardware. So it's very good when the two PhDs out of Georgia Tech that created this have applied. They also have a lot of experience in computer vision. So they take their AI, put it at the edge, take any video stream and then analyze it for driver compliance to make sure they're not falling asleep or distracted, or for any kind of security camera. If something happens, they can send an alert back to people to respond. So it's very exciting technology. So let me get into why we're here today. So our panel has a lot of experience in the IoT space. So Mike, let me start with you. Give me an idea of what it is that is of interest to you, and what is the most exciting thing you're seeing happening in the industrial Internet of Things and the smart marketing space.
So we're seeing more and more IoT and more of a, I call it genealogy, and that is from the beginning of a product to the end. So products that are being tracked or traced through the manufacturing process all the way into the customer. We've heard other speakers talk about that in other terms today. So you get the whole number of times the unit gets tested in the factory, it's recorded, all that data is there, goes out in the field, how it's being used, whatever, and when possible that data is given back to the factory or to the design house that did that, as well as if there's any customer calls or whatever with that product. And for most of us, it's not consumer, so I say customer, it's industrial in nature, medical in nature. But having that genealogy stored or transmitted back via some wireless means is the new trend of wireless.
Great. Jim, do you have experience, or let me go to Jim here first, and then we'll say Mubin, because he has a global view, and Jim has an experience in other supply chain needs.
Yeah, I'm probably more in the micro view as opposed to the global view from it. We've been working with a lot of different companies in the IoT space, and certainly some in the manufacturing space. One of the things that I noticed around here is that a lot of it is talking about manufacturing from the perspective of I bring in some steel, I bend it, I do something, I send it on out. We've been working with a lot of also companies in the manufacturing space, if you will, more from the process industry. So where you have a continuous process, and it's a very different space because you are, we can get into it as we go with things, but when you have a continuous process as opposed to a manufacturing process, you don't go down. That's the whole key. But in terms of the technologies and the things that we're seeing, obviously it's been exploding in the last couple of years. I think the Wavetrix we started 17 years ago. The big difference that I see at times is that it's the growth of all of the elements of the technology that have come up. And so now when you want to go piece all together those pieces of those technologies together, the difficulty of it is completely different, much more straightforward. All the pieces are there. The one example I'll give is when we worked on a location system, and for the longest time, you could go create a location system, but you could give the service away. I'll tell you where everything is. And the company couldn't afford it. And like, why couldn't they afford it? I'll give it to you. Because my back office has no place in it that says where the location of this device is. And that will cost way more than the whole value that you could possibly create to, because nobody has it. Now, if you go buy an ERP system or upgrade it, those data fields are sitting there waiting to be populated. So that's a very different in the ecosystem as it has evolved over the last 20 years.
Wow. Well, B, what is the interest that you have and what experience, what's exciting that's happening in that space for you?
Yeah, so when we look at manufacturing or smart manufacturing, we look at three things from our customers' lens. One is inbound, outbound logistics. So in manufacturing, there are things that come in, things that leave. And how do you manage those? And there's an IoT component around supply chain and outbound logistics. That is valuable not just for the manufacturers, but the entire sort of value chain of manufacturers, distributors, wholesalers, all the way down to the retailer. So instrumenting that supply chain is really important for everybody that's involved. So that's one element of manufacturing that we are actively working with customers on. The second area is what Mike mentioned, which is connected parts. So whatever you're manufacturing, you instrument that thing. So if you're manufacturing an industrial oven, or you're manufacturing a car or a tractor trailer, do you instrument that at the assembly line? And we're starting to see a lot more manufacturers think about that. You know, IoT has been an afterthought. It's been, okay, I'm manufacture something, and at some point in time, I'm going to put a device on it and capture location or some other sensor data. Now they're starting to think about, how do I build it so that it is connected out of the box? So I think that is a very healthy trend that we're seeing, and we're working with people who manufacture, whether it's tractor trailers or other things. The third area in manufacturing is the actual manufacturing floor and assembly line. So there's a lot of process engineering and analytics that can happen around inventory controls, or which line to shut off and which lines to start, or getting data off of the PLCs that have been there 30 years, but it's not easy to connect them. And then the factories of the future are like our workspaces. We used to work in offices and cubicles that were assigned, and now we're in fluid spaces where you can move the tables, desks around, and manufacturing lines are becoming that too. So there's no place or less place to wire things up in a hardcore factory. And so a lot of it is turning into IoT solutions on how do you instrument a factory of the future. So I think those are the three areas that we look at when we talk to our manufacturing customers.
Great. There's a lot of technologies that are being brought to bear to create the smart manufacturing facilities and industrial Internet of Things. Mike, tell us about some of the things, the technologies that you're seeing that you're using to create solutions.
So, a lot of our customers, our non-technical customers, come to us and immediately assume that the answer to everything is Wi-Fi or Bluetooth, because that's what they see at Best Buy. And it's our job to introduce them to other technologies that might be useful in IoT. So obviously cellular's one of those, but there's other like LoRa, V-WAN, and more. But the idea is that there's other radio technology to use, and it's not a one-size-fits-all. So we're with like all of our customers, they come to us with, and they tell us what we like when they tell us what they want to do, and it's our job to tell them how best to accomplish that. But more and more things are some sort of, usually a cellular component, so you can communicate when you're not in a fixed environment where there might be Wi-Fi infrastructure, and then other radios added to that to communicate with sensors or other gadgets.
How about you, Jim? What technologies are you using that you find useful and exciting to you?
First and foremost, it's all as Mike said, whether that's wireless is certainly number one on the list. Wireline still actually shows up, not modems, but internet still shows up. Connectivity is certainly the first and foremost. And then after that, you move into the sensor world. And in the sensor world, it's all over the map in terms of things. And certainly with, especially more now on the camera side, the technologies and vision systems, that's really, really changing that dynamics tremendously. I mean, 5 years ago, you could not think about, I'm going to look at a part and make a decision in 10 milliseconds. what they're going to do. Today, that's just like, oh, no problem, you can go do that.
Wow.
So that part has changed. And obviously, the other big part that has changed is on the other extreme end, the cloud. You know, the data is typically going up somewhere, typically in the cloud. Not all the time. All depends on how the company views the world and as to how you know, how they want to protect their data and store their data. But all the cloud and then the ability to do the analytics, I think you're starting to see slowly kind of a bifurcation where you talk about things that are kind of, if you will, at the cloud, which are trying to predict longer term things, you know, the preventative maintenance, those type of activities, as opposed to the things that are potentially down at the plant when you're trying to control processes or try to flag immediate events that need attention. So I think those parts are starting to kind of diverge a little bit and starting to evolve because there's really multiple different consumers of the data that's being generated by all these sensors. I think one of somebody, I guess earlier in the talked about how many 6 billion pieces of data was being generated out of their plant per year, and you're like, how are you going to analyze that data? And the point is, I think, the big part is we don't know who's going to analyze it from what dimension. There are going to be a lot of people who want to analyze it, but they all have different perspectives, from whether it's the manufacturing engineer, from the process engineer trying to optimize the process, to the development engineer trying to figure out how well does the part work, how long does the part work, how can we improve it, to the guy on the shop floor trying to figure out why all of a sudden tolerances aren't meeting when he's inspecting something. So I think there's a lot of those pieces.
Good. Well, Bean, you're in the AT&T family, right? So you get to see a lot of exciting, new, innovative ideas. What kind of things are you seeing there? What kind of technologies you bring about to bear?
Yeah, so Foundry, for that I mentioned, is really our innovation lab. Three types of projects we do there. You know, just sort of general innovation around technology, whether it's 5G stuff or new device sensors and things like that. But then also some of the product innovations that we do around network technologies or platforms. But the most exciting part is actually working with customers. So we, you know, almost on a weekly basis, we have customers walking in and they plop down some asset and say, this is what I want to instrument. And there's no one answer to your point earlier. You have to look at, understand what business problem they're trying to solve and how do you instrument it best. So, you know, if you walk into a foundry any given day, you'll see a wheelchair being instrumented on one side, you'll see a porta potty on the other side, you'll see you know, a container, a pellet, you'll see all kinds of stuff. So some of the areas where we're seeing, obviously devices is an area where we work a lot with the customers. And it sounds very non-exciting, but in the device world, there is no standardization. There's no standardization around the size and the way the devices talk, and each asset you're trying to connect is unique. So what we're talking about earlier, where we 3D print some of these devices, 3D print the circuits, try to fit it into the things in the right, whatever space you have. You have temperature, humidity requirements, all kind of sensor requirements. Sometimes you have to hack into the Modbus equivalent of the whatever that thing is, or the controller, to get the data off. So there's a lot of exciting work that goes on, and that's how IoT, that's the stage IoT is today, because most things are not designed to be connected, and we're trying to connect them. And so you have to do a lot of like a hacker type of work to actually get them connected, and that's why all of us are in business.
Right. So, Mike, we're talking about all the technologies here, but the real, where the rubber meets the road is the business models. Do you have ideas of how the business models are evolving, or what business models are the most appropriate for your industries?
Yes, so we're an engineering service firm and develop products for the people. One of the first things we do with them is to try to understand what the business is that they're in and help them understand what the model is going to be and how they're going to sell that product. Is it an asset we're going to make? design, they're going to sell, so many dollars per each, or is it software as a service or something? And we're kind of seeing across the board. We've got one product that's a global product, and it makes sense for it to be disposable, which is a bad word, I know.
Yeah.
But you can't ship back a device internationally cheaply back to the U.S. one at a time. So it ends up being disposable. We have other products where one of the clients we developed a product, and now it's transforming from a per unit sale with a per use service fee for the service use of the product. Now it's going to be completely software as a service. And the company's in a position now financially and success-wise where they can afford that CapEx expense to go build a bunch of units that are then shipped in the field and available to print, use on demand, if you will. So I think it changes, but I see much more stuff with the cloud being that the cloud's the most important. And in fact, my caution to all, or my advice to all is make sure if you've got a product that, and the data is being stored in the cloud, that you own the cloud. When I say own the cloud, you don't go to Microsoft, but or whatever, but you need to know that you have access to that. That's your data. Don't entrust to some software group that may have developed your back-end software, because if they control the back-end server in the cloud, they control your company, regardless of whether they're a shareholder or not. They effectively have 100% of the shares of the company for control. And it happens all the time where startups, they get a good deal from their software developer, and they've got them held pretty tight there with them in the cloud. So that's my advice.
Jim, what about you? Business cases that you see?
The business case is always the most interesting one because I'm sure Mike can tell you, but I'm sure well over half the people that show up, what business case? We got something here, we want to put a sensor on. I want to monitor this, I want the temperature, I want some vibration, whatever. And then you start asking them questions. So what are you going to do with the data? How often do you need this data? And what and then I'll say that the business case comes down to three answers come out. The great answer is, here's a straightforward business case. It says it's going to cost X to do this, it's going to cost this much per month, I'm going to save this much per month, I pay it off in 18 months. It's great, everybody wants things. A lot of them end up into, I don't know how this is ever going to pay off because there's just no way you can afford this type of activity. And then the third one just ends up finally being the case of, I don't know, but we gotta go because our competitors are going, the world is going, and we know the process will change. And that's, I think, the big thing. The business, or I shouldn't say the business process, the manufacturing process, the processes underneath that are going. If I don't evolve that, then I know that I'm going to get left behind. And so that's obviously a much tougher sale. I think a lot of the other part of the business case is there's kind of the other way of cutting it and looking at it in two things. One is the incremental change. Somebody described earlier a foundry tool as it warms up, and okay, can I monitor the temperature to figure out it's gotten too hot and I shouldn't be running it this fast, or I should cool it more, or et cetera, however I want to do that. Very straightforward, simple business case, as opposed to, all right, I want to redo my whole manufacturing floor. Now that's a whole different world that you step into. So if I want to truly embed it, it's kind of the difference of GM trying to build an electric car versus Tesla coming out with an electric car. One guy's coming in like, well, I got all these things I can just kind of jump on and tie in. Does it make sense? I don't know, but I got it, and I'm going to go use it. And so it's always, I think, a battle between those two types of rules.
What about you, Moby? What kind of business models are you seeing out there that are exciting?
So the business model for us from an AT&T as a supplier is pretty simple. It's we like per device per month charges as a carrier. So for networking, that's close to $1 a month, for general connectivity, IoT connectivity, and if we're selling applications and solution, it goes to maybe in the teens per month. Okay, so that's simple, easy. But on the customer side, the business models are all over the place. And I'll touch on a couple of customers recently that we've worked on. So I think we were talking about a cooler manufacturer earlier. So a cooler manufacturer comes up and business case was, they thought through it. Hey, 3% or 5% of my coolers disappeared. They're not at a location that I thought they were, and or somebody steals them, some of the smaller sizes. Okay, so they do, they say, I want to be able to just get location off of it. And they do the math and they say, okay, if it's $8 a month solution, and the cooler costs $500, and 2% disappear, I instrument 10,000 coolers, I get my ROI, 18 months, whatever. So simple. But what happens is that these business models evolve. What happened after the first trial that we did is they said, now that I've instrumented the cooler, what other data can I really get off of it? And they say, oh, can I get compressor data off of that? Yeah, you can. Okay, excellent. So now I can get vibration. If I analyze that vibration, I can probably predict when this compressor is going bad or about to go bad, and maybe I can offer better warranties or management warranties. Then they start thinking about, can I get temperature data inside the cooler so that I know at what temperature the beverages are being held, or ice cream and whatever, and provide that information to my customers so if there's going to be fear of spoilage, I can give them alert. Interesting, okay. Now the business model has evolved. Then they said, I want to put a camera looking at inside the cooler, because some of these coolers I sell can only carry the red beverage and not the blue beverage. Okay, so compliance, another use case, and the business model evolves, because now I can tell that this is a red-coated cooler and you cannot put a blue beverage inside it. Then they want to put a camera outside to look at how many people actually crossed in front of it and how many people opened the door. So what's my marketing return on that cooler in that location? So that business model continuously evolved in almost every single use case over a period of, I did this exercise maybe a year or so ago, every single use case in 18-month time post-deployment, you see it 3 times X of the use cases of what they actually started. So that's a healthy sign. So I think the business model starts off somewhere, but it actually starts to incrementally go into a direction that's very, very, very good for the customer.
Awesome.
One other comment on that.
Sure.
So we see the same thing, and we'll talk about the customer, what they can do to monitor. But the reverse also happens, which is, let's put the kitchen sink in it to start with. Let's monitor all this stuff, but they don't have there's no money really or cost or value or ROI. They've calculated all of it. Let's say the camera. Use your example here. Maybe I thought through that. So it's one thing to add temperature. Maybe that's a quick sensor to add. Why not? But to go add cameras and then back in analytics, and then they have to have more data to transfer back and blah, blah, blah. And now they lose sight of what they started off with because they're sometimes thinking maybe too far ahead or not really having the costs. Too ambitious.
Just, exactly.
Okay.
The biggest thing is you run into the first one is your example, nice, easy, okay, I can understand the business case. The other alternative is, when I add all 28 sensors, now the business case may work, but oh my God, the cost to get there on day one is huge, and I don't know, will this really help drive? How much more marketing do I have to get? How much of this do I have to get? How much? Okay, now all the assumptions get huge, and so you run into the opposite problem of it's the elephant that just squats and that's it. You can't go anywhere.
So Jim, you got the mic. So do you have some use cases and examples of how IoT is being applied that's either interesting, fun, or unique?
Probably the most interesting one, one of the ones that we're currently working on is in the process industry. And watching the customer go through their thought process on the business model. It's fascinating because you can read, Mike and I can tell you, we can tell them a little bit, but we don't know anything. I mean, we understand it. So you get it, but watching them go through. So you think in the process industry. So the process industry, there's you schedule downtime. So I'm going to do predictive maintenance. What does that mean, though, in the process industry? Because here's the downtime. I don't care if it's going to last 3 more months, because I'm going to do so. What's the business case again? Because of it, or you know, how is the business case? I think in this particular example, part of the business case is the devices that they're building that's in these big processing plants, is how they can help their customer use them more efficiently by maintaining them better, which means, quote, they will sell fewer of them. But if they don't sell fewer, their competitor will do the same. So there's a little bit of the dog-eat-dog world that goes on, especially in the old growth industries. You know, yeah, if you're in the software as a service type thing, and it's growing and it's booming at 50% a year, and okay, I got to cut it to 40, I don't care. But when I'm going to say I might hit the top line sales and maybe hopefully get it more back into maintenance, those are tough decisions for the customers to make, and so watching them go through that process is an interesting experience, and nerve-wracking because you're trying to sell it.
Interesting. Mike, do you have some interesting use cases and examples of IoT that you find interesting, unique, or fun?
Yeah, we can talk about this till about midnight. So I'll pick one. One is a shipping container product we're doing that is a breach detection device. It's a device that goes inside a shipping container and determines if it's been breached. It's got all kinds of proprietary sensors and stuff, and it'll determine if someone's broke in the shipping container. There's no external antenna, so we've figured out a way to have a cellular product work inside of a shipping container.
Which are typically all metal, right?
It's a Faraday cage. That was miracle number one. But part of that is getting to that point took us a long time, because the customer originally came and said, hey, they have these little metal seals that go on the outside of the container, and they're bolt cutters, you usually get them off. And currently, people can get in the shipping container without ever cutting those bolts. And so we just need an electronic version of a bolt that can't be cut, and something mounted outside. So we started with basically an electronic lock. In fact, CES offered one last year that you put your fingerprint on it and opens, and ooh, cool. Except that wouldn't fix the problem that we're really trying to solve. Without going into all the details, because we'll be here at midnight, is we ended up going through various different technologies, and we would maybe do Wi-Fi. We realized we really can't do Wi-Fi in the yard. We can't trust that yards all over the world have that. We talked about cellular. And so we ended up with cellular. We use 2G because it's the finest technology in the world. Now, hold on. I'm sorry that AT&T's here. We can't say that.
We don't have it.
I know. I was going to say
so we do 3G too. But the reason for 2G is radios are cheap.
Yep.
And it is ubiquitous through most of the world.
Right.
Except Japan, Korea, and then there's that other company here in the U.S. temporarily. Because this is a disposable device, I don't need to worry about my product lasting 7 years. It needs to last a few months. So until T-Mobile shuts off the U.S., that product's still viable for containers. Oh, and by the way, very few shipping containers actually go into and from the U.S. Okay, that's exaggerating. But it's not the whole world. There are hundreds of millions of containers that transfer every year. And if they don't touch the U.S. soil, then we're still fine. So again, so we get laughed a little bit when you think about the lower radio, but I don't need LT. In fact, I can't use LT in a lot of countries. So Rwanda and all these other places may or may not have the higher thing. So this was unique, is just trying to figure out how to do that. The second part of that was, the second magic was having a SIM card that works in 190 plus countries. When we think about our iPhone, it's great. It's got all the antennas. Where, but you got to change SIM cards if you go to certain countries. Here was a product that we were able to do that with. So most of those two miracles are done. The rest of it was pretty straightforward.
Awesome.
So that we were excited about. It took a long time, and now it's beautiful.
How about you, Mobeen? What kind of exciting IoT use cases or examples would you like to share?
Yeah, so let me touch on two of them. One of them, it's actually a very simple use case, but we're finding a lot of traction in manufacturing, retail, and customers. It's called IoT button. If you've heard of an Amazon button, for example, Wi-Fi enabled order button, you run out of time or whatever. So this is think about it as an industrial use case for that, or an enterprise use case for that. So it's a button uses LTE-M today, would be narrowband IoT in the future as well. It's a little half the size of a hockey puck. Has a button. And you put it wherever you want to put it, and in the back you have a simple coding to say what happens when somebody presses a button. It could be as simple as send somebody a message, a text message, or send somebody an email. Or it could be as sophisticated as open a trouble ticket in Salesforce.com. So think about putting that in outside when you run out of coffee in a conference. Or you put it in the facilities to come in service. Or you put it on a manufacturing floor, press the button, and you get inventory. So we're finding this in hospitality, manufacturing, retail, theme parks. They're deploying this use case. Very simple. It's a button. Anybody knows how to use it. But each button could be designed to uniquely start a process. So it's process innovation through IoT. So that's one use case that we're working on with a lot of customers. The second one I'll touch on, one of the largest categories that we service is vehicles. Vehicles. Things on wheels. Cars, trucks, trailers. So when you buy a GM car, it has an AT&T connectivity inside of it. The typical use cases are GM reading off the engine diagnostics and other things from it, and then providing you with a maintenance schedule and so on. And a second use case is us as consumers. It has a Wi-Fi hotspot that we can connect, download our movies, whatever. Well, not while driving. In the back seat.
The kids.
That's for the kids.
So those are use cases. But what we're finding is that people who provide subsystems in a car want their own data feeds. Okay, so a battery manufacturer who sells batteries wants to instrument the battery so that they can sell you another battery before your battery goes down.
Really?
Yeah. So GM doesn't need to know that, but the battery manufacturer wants to do that. A tire manufacturer, especially in commercial vehicles, want to monitor the tire, the pressure, and whatever other things they're monitoring, and put a sensor in it. And they want to sell you tires before your tires tread goes too low.
Tires as a service.
Yeah.
Wow.
Manufacturing, the manufacturers of chassis and engines and all those sub-parts inside the vehicle, they all want to instrument their own. So think about this. A vehicle can have 8 to 10 different connections going directly to different manufacturers because they don't want to share data. Or they want to beat a path to you from a marketing perspective to sell their wares, as opposed to taking you to
The dealership. Yeah.
So that's an interesting set of use cases that's evolving.
Awesome. You want to add something?
Yeah, you just hit on the other part, back to the business case, which is the whole ownership of data.
Yeah.
And that just, I've seen that kill more IoT applications than anything else. Just because nobody wants, it's my data. I mean, we're talking manufacturing. If you go on the home side, the whole Google thread, we talked to a number of companies. And
I stay away
it was a dead end street because it's like, no, it was just an argument that you're just not going to win. And everybody was, and that's I think why you see, even in the home space, there's very little integration going on because they're all arguing still whose data is it. It reminded me of years ago we worked with a company that was doing, wanted to do grocery carts. It was, they're trying to monitor, collect all the data, what's going in your grocery cart, for they can sell that to the store and they can sell that to the food manufacturers, and you can guess they're beaten up like mad by both sides. It reminded me of my roommate from college. He used to say, if you really want to get killed, tell somebody you're a moderate in a dictator country, because both sides will try to kill you.
Okay. Interesting. I have another 2 pages worth of questions, but let's open it up for a moment. Does anybody have a question that you would like to ask one of these panelists? Something that's a burning question these guys have been involved in the industry for quite a while and are seeing a lot of developments taking place. So if you think of something that you'd like to ask, just let me know, and we'll jump into that. Now, one of the things that we haven't talked about so far is security. So how important is security in Internet of Things, particularly industrial and smart manufacturing? Oh, got a question?
Double check.
Well, okay. I was kind of running on there to see.
Let me run one.
Okay, Gary.
Let me run one from the floor here just to get us started. As an operations guy, manufacturing operations, a lot of process engineers, manufacturing engineers. I'm looking at IT versus OT right now. Okay, so if you're a process engineer, the IT department is the geeks over in the corner that keep your computer running. So when you're on a break, you can go and look at your emails. Okay, and the process engineer says, look, I know all these things. I know all the dials to do, and I've spent a lot of money on automated equipment that collects thousands of points of reference that are never used, thousands of pieces of data. So what I'm saying is, what is the change? What is the motivation that's going to get companies to embrace this IoT in manufacturing and better utilize all the data that is available and make it profitable for the company to get the engineers to talk to the IT with the OT?
I think it's similar to the hardware-software discussion. Electrical engineers, software engineers, in the old days were fighting all the time. Software's not really engineering, it used to be said. And now hardware's got a necessary equal. And I go both ways so, on that. Here's the deal. I think it's about the ROI. I think it's got to be driven from management down, not from the floor up. I think it's got to be, what is the ROI? Why do we need to do that? What's the value? What are we trying to accomplish? And if everybody sees it's like any other thing when pushed down in an organization, everybody's got to see the light and see why it's important and how the data is going to be used. Nobody wants to produce data if no one's looking, if management above is not looking at it, and vice versa. So I think it's got to be a push down, and it's got to be shown where the value is.
Yeah, I go back to the three areas in manufacturing that I was talking about earlier: the inbound, outbound logistics, the connected product, and the manufacturing line. The first two, we're seeing no debate. That's inbound, outbound logistics is run by the operations folks and supported by IT. The connected products are run by the marketing department. So that's who owns the data, that's who owns the decision making, and so on. It's the manufacturing floor where this problem that you're talking about exists, and that will be, to your point, a continuous debate. And it will be, I think, for at least foreseeable future, the OT folks own that floor. They are not going to let anybody in, either whether it's third-party vendors or even the IT departments, and they decide at the end of the day because they own the manufacturing floor. That's how I see the world today. And there's no indication that I've seen that that's going to change anytime soon.
Pete?
So, and this is for all of you, in designing IoT applications, right, the use case is important. One of the things from a design element perspective is the decision making and or latency aspect of the use case. How do you best design that in? I mean, case in point, I know this is a manufacturing format, but it's easiest to use an autonomous vehicle application, right? You could be designing autonomous communication where a car has to make 1,000 concurrent communication sectors, okay, as well as make really sub-millisecond decision making to navigate a road, to make a turn, or to decide whether you're hitting a child or a deer, okay? How do you and obviously, if you're talking about small packet, those criteria are engaged as well, but how do you work on those design aspects?
So I'll give you AT&T perspective, but...
And obviously this is a 5G answer for you, right?
Well, it is. The thing is, level 4 autonomous is one of the toughest problems in this space right now, and for a variety of reasons: policy, human nature, human behavior, as well as communications engineering.
Right.
But just talking about the communication engineering piece of this, network will play an important element, but a lot of the smarts probably will be in the vehicle. And it has to be. Because if you're looking at, the networks will go to maybe millisecond kind of thing, but in a lot of real-time decision making, that may not be long. That may not be enough.
Right.
So I think there's an aspect of vehicle-to-vehicle communication, there's an aspect of vehicle-to-infrastructure communication, and there's an aspect of network communication. A lot of the decision making in those scenarios will be at the what we call true edge, and that's where the latency will come in. But in control systems, if you go away from autonomous, you go into control systems, like inside of manufacturing or other closed-loop control systems. That's where I think 5G, maybe even some level of 4G LTE advanced with maybe sub 50 millisecond latency can actually work pretty well. That's how we think about it. And again, it's all dependent on use cases and so on. But level 4 autonomous is the hardest problem to solve.
Right, and then I know for vehicles, the NHTSA requirements go to level 5 in 2023, if I remember reading the specifications.
I don't know if I'm confident that we'll be there.
I understand. And building in that for Mike and Jim, on the plant floor manufacturing facility, have you been designing systems with a lot of edge compute for the latency intolerant applications?
So, a couple things. I'm an AT&T customer. I love AT&T because it's covered everywhere, except there's always some place where you don't have coverage, or there's coverage for a millisecond or however long, just because of whatever, right?
There's a solid Frisco by the way, means you can
it's wireless. I don't mean that bad. And so any wireless technology, and so like he said, it's critical decisions have to be made locally. A large portion of our business is Class 2, Class 3 medical devices, which are things that must work and don't have an option. So, like he said, we've got to have a lot of those decision making's got to be done at the edge and right there, and then push off. The other aspect I'll add to what we do design-wise is a lot of our stuff is battery operated, and that really makes a change in where you make decisions. So we're doing a product right now that's wireless, and we need to do some video, or actually still pictures. I need to do image recognition, and I need to transmit it, and I need to have a battery life of 5 years, and I need a total product cost, including care, to be under $20. So I've already got more constrictions than I ever want to have. And I'm going to do image recognition. I'm not doing image recognition on a little bitty processor, on a little bitty thing that runs on a little bitty battery for a 5-year period. So I have to push that out. So that's fine. As long as we know that, we'll capture an image. We'll set it off, we'll barely compress it, and let some Core i7 somewhere take care of it. So I think every design we do, has to make a decision between battery and what can be done and what happens if. It's like any other design. You've got to go through a risk analysis and see what happens if. What happens if we lose wire? What happens if there is a delay? What happens if we're not on AT&T? What happens if we're on a small carrier somewhere in a foreign country? I mean, you got to know where you're at. Or you're in a rural area where there's just not much bandwidth. Anyway, I can ramble over.
I'll just add, I'll twist your questions. Clearly got moved to the edge for your thing, but I'll answer your question in a completely different direction, which is one of the biggest parts we see in IoT is all about installation, provisioning, and configuring. How do I get this done and done cheaply? I'll go back to the previous question. Okay, if I'm going to go put something in some guy's factory to monitor my piece of equipment, okay, I got, if you will, two communication options. I can connect into his network some way, shape, or form, Wi-Fi, any way to connect into his network, or I can go cellular. How much do you think it's going to cost for me to have this guy call up the other company, find out what the Wi-Fi password is, put this all programmed in, get this recorded, put it in, programmed, et cetera, how much is going to dwarf the cost of the sensor?
And then it changes.
And then it changes. And of course, when it changes, you're going to have that unobtainium piece that will tell you the password has changed. You know, it just went offline. Why did it go offline? Because it's badly operated, the battery died?
No, your design was flawed.
Yeah, exactly. Which one is it? You know, you can't tell. So the installation, configuring, and provisioning it, we find is absolutely critical. That drives the cost. It's back to the car example. It is why it is the first, you know, between it and ownership, why people you're going to have 10 modems in your car is because it's easier. And because if I have to try to get all my guys, talk to all these guys, and make everybody communicate and understand all each other's protocols, it ain't going to happen. I mean, the standards committees are wonderful, they're great, but they don't move at the pace the technology is moving at these days.
Very good. Yes, Lisa.
Cloud versus edge. Are you seeing a lot of cases where companies are growing up? The question is kind of two-part. Cloud versus edge. So you're seeing examples of where companies are growing up and putting a bunch of data in the cloud and it just costs an extreme amount to get it back. And then how quickly do you think there'll be more edge computing taking place to upsert what's going to the cloud now?
That's a great question because I think there's two parts. First of all, there's two answers to it from the perspective of when you first go and meet them, they'll say, we're going to do it all in the cloud. And you go, well, why don't you go out to AWS and just kind of play with your little calculator to see how much it might cost per month. And then they come back and go, is there another way we could do this? Because all of a sudden they realize, bandwidth costs money, storage costs money, processing costs money. So all those things. So I think it all comes back to the specifics of the case. There's clearly some places where, as Mike had pointed out, you know, by the dynamics of the situation, I got to go use I got to leverage the cloud. You know, on a per compute basis, you're not going to be able to compute at the edge. It's going to cost more to compute at the edge than it ever will in the cloud because I can aggregate it so much. If I got lots of processing, the cloud wins. But then you get into all those other constraints, things like batteries and the connectivity and latency and et cetera, and then that kind of pushes you back towards the edge. And obviously the other thing that you have going for you is still Moore's Law, is still alive, still going, and that cost for computing at the edge keeps dropping. And once it hits a particular threshold, it's going to move to the edge, right? It still comes back to the cost. It may still be cheaper in the cloud, but really on the total on the device, it just makes it cheap. It's so small of a difference. So I think that makes it all depends on the specifics of the case, but there are certain trends that are happening.
Mike, we'll give you an ending.
So we are not going to win this war. Cloud's going to win. So I agree that we want to do things on the edge, but we're being driven by companies. For example, Office 365 is in the cloud. One of these days, it's all going to be cloud. Adobe software as a service. Everything's moving that direction. Right or wrong, doesn't matter. It's going that way. I'll give you an example. 15, 20 years, we designed the first dog collar that had a cell phone and GPS tracking it. It was huge by comparison to the ones you get today at PetSmart, but it worked. Now, why did we not, when the pet's lost, which we knew, why did we not send a text message or an email to you, the pet owner?
Or the dog.
Or the hey dog. But why do we not send it to you directly? Why don't we go through a cloud? That was before the word cloud was used. But why don't we send it to a server and then to you? It's because we want that monthly fee. We've got to have a monthly fee. We can't just sell you a $100 product that then it automatically emails you and we're out of the loop. We need some revenue. So everything's going that way. You just talked about $1 per unit, or everything's about per unit, per month, per this. That's the AT&T model, and everybody else is kind of catching up, if you will. And so I think whether we do more computing in the edge or in the cloud, in the end, there'll always be a cloud component. So there can be a recurring revenue. They can control or own, whichever word you want to use, the data of yours or theirs, whichever, but they control it, therefore you pay for it.
Yeah, I would just say it depends on the use case. And there are certain use cases where edge is going to be critical. Peter asked about autonomous driving, and vehicle telematics in general tends to be very edge focused. control systems, very edge focused, all kinds of image processing, video surveillance kind of things. You may not want to send all that data back. You may to do some processing there and say, oh, I see a silhouette of a person, or is it a dog, walking by? And if I can distinguish between the two, in one case I won't send any message, in the other case I may send a message, there's some intruder around. So it depends on the use case, and more, you'll start to see a lot more edge processing happen in use cases, so that you just pass the insights, if you will, back to the cloud.
Or the events or alert.
Yeah.
Yeah.
Or actions you need to take.
Okay. So I know we're about out of time, but are you seeing any pushback either from like a manufacturing facility and/or in the case of maybe GM having all the antennas and things put into their product or into their facility? For instance, you're going to put a, well, you said, for instance, you're going to put a device in a manufacturing plant, and then you're not going to use Wi-Fi to send a signal back, you're going to use radio, cellular. Does the factory owner have an issue with that? And if so, what are you seeing with that? Because it seems to be a privacy issue, a security issue, that sort of thing.
So I'll give you I'll answer your question differently than you guys can answer the proper question. I have a CPAP. It has a cellular radio in it. If it hadn't been for me being a geek and read the manual and all that stuff before I take it home, I would never know that my new machine has a radio that communicates back. I never gave authorization because I'm clear about my HIPAA stuff. I never mentioned that. But when I went to the doctor the first time to review, he asked for my SD card. He said, it has an SD card too, I forgot it. And he said, don't worry, just pull that up. And so the doctor's got it, ResMed's got it. But my wife doesn't know that hers has a cellular radio that communicates daily on her sleep activity. Luckily, I'm 100% compliant, so I'm good for once.
Yeah, I think depending on where you deploy these devices, I'm sure there's all kinds of standards that are there on all kinds of manufacturing facilities. So for example, this is about a few months back, we were working with a company that has oil and gas processing facility. And the requirements of putting anything in there is extremely strict. Intrinsically safe and this and that. And those devices that would normally cost $100 or less to put in cost $2,000 because they are in these kind of specialty packaging that before they can get deployed. They cannot. So it depends on where you're deploying it. In case of HIPAA or things going into medical devices, you have all other things that you have to worry about. So it really depends on where you're deploying these devices and how you can instrument those things.
Okay, Jim, we'll go to you, be the last one. I think we're just about out of time.
We're just about out of time.
All right, so we'll let Jim finish up.
It comes back to, in the end, what does IT want? Generally, IT says, don't put it on my network. If it's not on my network, I'm not responsible. That's the unfortunate thing, that's the biggest response we see, is that, and then this is back to that OT versus IT world. And then the OT guys in part like that because they get to sign up and they don't have to get permission from IT. You don't have to talk to IT about it. So that's the thing, but you brought up an absolutely critical piece, which is the requirements to be in some of these places are just ludicrous because of the things like explosion proof and intrinsically safe. So it all comes back to in the end, domains. And it's easier to deal with, to keep the IT guys away from it because they don't want that stuff, talking somebody else's piece of equipment talking through theirs. They just don't like it.
Okay, so the last point today, we've been recording this presentation today, so if you would like to review this or tell other people about our panel today, you can go to my LinkedIn profile at Hightower or to Tech Titans, which will be eventually
Do that the next day or two.
All right, as soon as I get it edited and uploaded to you. So I want to thank, pardon?
That's what it's nice for.
Yeah, and I want to thank our panelists today. If you would join me.